Alright, Mr. Felice here from Advanced Quantitative Reasoning. We're going to be talking about concentration in medicine. A student asked me to go ahead and show this all, so I'm going to be doing this a little bit weird. Okay, so we have this medicine called Sneeze Be Gone, and the regular adult dose is 20 milligrams, and that's 30%, and 30% is flushed out of the body. You know, in other words, we just take it in and it goes right out, about 30%, and it takes about 24 hours to happen. So if 30% of it is removed out of it, that means 70% stays inside the system. That's just how it goes. So if we're looking at this information, we're trying to go ahead and populate this graph. Of course, mine is already populated, but not everyone has this. So I'm going to go ahead and grab my trusty calculator and show you how to do this. So first off, we start with a couple of things. It's best to go ahead and have this thing round to the nearest tenth. So if I just type out 1.56, it'll automatically round to the nearest tenth for me. So that's how that works. So now we start out with 20, and of course it does that automatically, so 20.0. So we've entered in 20, and it's saying right here, use the recursive feature of your calculator to fill in the table below. Assume that the audit is 20 milligram dose. So we're going to be doing this right here. We have 20 milligrams. I'm not showing you all of it. So 20 times, so we take the previous amount, so I hit the times button, and it brings up ANS times. What this does is automatically put in this command, which takes the last number and puts it right there, plus the daily dose, which is 20. So let me see. Oops, made a mistake. Oh, I forgot. Daily dose. Okay, do this again. So we have 20, push enter, times 0.70. This is the amount of medicine that's going to stay in the system. 70% of 20. That would give me 14, but I'm going to be adding also another 20. So that gives me 34. So I write that down on my chart. Hit it again. Gives me 43.8. If I hit it again, it'll give me 50.7, and so on and so forth. And so you can see that it just keeps on going, and then it gets to 66.6 as our level off. So that's our level off at about 18 days, 66.6. Takes about 18 days to go ahead and get there. And the students, okay, well, we're not going to be worried about. This function is a special one. It's a type of stepwise function, and it ends up something like this. If I go ahead and draw this out, we end up with a function that starts right here and goes down 14 points, and then goes, when we draw this originally, we have this right here. We go ahead and end up with something that looks more akin to logistic. But if we were to go ahead and map out one day, in other words, right here, would map out the amount for one day. Well, this part right here would be 20, because that's the beginning amount, and we want to go ahead and mark out how much we have at any point during the day. So that's 20 times 0.70. This is exponential decay. So to get that, you just take 1 minus 0.30. That gives you 0.70 to the power of x minus 1, because we want here at 1 for this to start at 20. So that's how we go ahead and do that. Then we have to restrict the domain. So we're doing this from day 1 to day 2. So from day 1, it's less than or equal to x, and then x less than or equal to 2. Now, for days, it's going to go ahead and work out this way all the time, for each one of these, because that's for day 1. Day 2 is the same thing, but we went up right here, and it goes down again. And then it does that again for the next day, and then the next day. So if we want to write out all the functions, because this is a stepwise function, we're going to put these all together. The next day, instead of 20, we use whatever information we have here, which is 34. So just write down 34 times 0.70 times to the power of x minus 2, because that's day 2. And then we go from day 2 to day 3. I made a mistake right there. That should be not less than or equal to on that one. Then day 4 or day 3, we have 43.8 to start with. So day 4, 43.8. We just changed one little thing. We changed the beginning number times 0.70. X minus, well, the day is now day 3, so we put x minus 3. And then we have starts on day 3 and ends just before day 4. And that's the meaning of that. So throughout right here, we have graphs that look like this. That's the way it's supposed to look. Now if we look at this right here, that's what we have. That's where it's starting, and this is where it's all changing. This is only 7 days, so that's how it looks right there. So I've already gone ahead and done this for everything. Now we move on to part 2. So right here, a couple of other things. If we're looking at our maximum and minimums, we start when we get to, let's see. Okay, what would the minimum amount of needs to be gone be in the system? So we have a maximum amount and we have a minimum amount. So when we hit our level off, it's actually 66.6, spooky number. Alright, now we have this one as our maximum amount. Our minimum amount is going to be 66.6 times 0.70, which is 46.6. Now I want you guys to realize this is what's happening. Let me grab the graph again. When we get to this level off point, we keep on getting 66.6. So on this day we have 66.6, and then we're here at a minimum of 46.6. Well, that's very interesting because that has a difference of 20 milligrams. And our daily dose happens to be 20. So this is actually our daily dose. So what happens is throughout the day, we lose 20 milligrams and then we replace it at the beginning of the next day. So we're basically replacing what we're losing, and that's why we have a level off. And that's why the level off looks like that. Okay, so that takes care of that. Not going to worry about that any further. Now we have the different days. This is done the same way. If we keep on going, we actually reach 100 milligrams eventually. So our level off is actually 100, not 99.9. Okay, so our function rule would change just slightly. So we have our original function rule, which is 20 milligrams. Okay, no, wait a minute. 20 times 0.70 to the power of x minus 1, and we still have the same domain as the other. But this changes. This changes to 30 times 0.7 to the x to the minus 1 power. X less than 1 less than x, x less than 2. Alright, so that's about it. So it's asking what's happening between this and this. Well, it's very, very simple if you go ahead and look at one other little thing. I want to go back to this. So this formula is 20 times 0.7. Well, I don't need to. It's right here. 20 times 0.7 x to the negative 1 power. But if I were to change this to 100, say for instance I have 100 milligram dose per day, it's still the same flush rate times 0.70, x minus 1, and then the same domain, x 1 less than or equal to x, and x less than 2. So, same domain. Instead, it would be up here, and this is the way it would look. It'd start at 100 and then finish at 70, because we lose 30%. This one started at 20 and ended at 14, so that means that this is actually a vertical stretch between this function and this function. They're vertical stretches. Now what's going to happen constantly right here, if we change all these numbers, we're going to get a whole bunch of vertical stretch. So when we change those numbers, everything vertically stretches. And it just looks like something that's akin to this. So this is for the 20 milligram dose. is for the 30. And this one right here, I don't know what that's for. It's a new image. I don't really care. Okay, so we have a whole bunch of other things. So let's see. That's about it for that. So we have to look at this fact that these are going to be vertically stretching. Alright, so finally, I'm going to go ahead and show you one last thing. So this is what happens when you work through all the pages. When we have 20 milligrams, the flush rate is still 30%. The dosage over here is still 30%, and this one still has a flush rate of 30%. The level off amounts for these right here, this is 66.6. This one right here happens to be 100, and then this one is 133.3. So what they're asking us to do here is take the dosage divided by the flush rate. So let's see, dosage divided by flush rate. So this is 20 milligrams. For the first one, it's 20 milligrams divided by 0.3. That gives us 66.6. I know it says 0.7, but don't worry about it. Okay, so in the next one was 30 divided by 0.30. That gives me 100 milligrams. And then the last one, which is this, 40 divided by 0.30 is 133.3. So if you look at this right here, this is the different flush rates, and that's what's going to happen with this. Alright, so we have a couple of reflections, and I'm going to show you this. Basically, our formula becomes level off. To get our level off is equal to the dose divided by the flush rate. So we have all this stuff right here. So if you look at this one, it's saying if you were a doctor and you knew that the patient needed to have about 100 milligrams of sneeze be gone in his bloodstream for the medicine to become effective, what would you prescribe? Okay, well, we want level off to be equal to 100, and that's equal to our dosage divided by the flush rate, so it's 0.30. Then you just multiply. You solve for D. So these cancel. 100 times, and I think that's going to be a 30 milligram dose. Yeah, it's a 30 milligram dose. So dose is equal to 30. So eventually we'll reach a level off of 100 milligrams. And that's how that works. And I know that this is one of the answers from the other questions. That's why I changed this inside of class, and you're going to be answering it differently. Now we have this one right here, which is a new cholesterol medicine, has a flush rate of 50. I'm going to be comparing that inside of class. So I'll see you guys later.